Okay, fine. So we decided to say the point A is in the first quadrant, having the coordinates T and T. And we said here, we are just going to have the point B, which is any point that is on the circumference of a circle. So we don't know the coordinates of B. So we're just going to call them X and Y. That's fine. But then they said from B, or rather from a tangent is going to be drawn. And this tangent is going to, I don't know it's going to do what, but it's drawn from B. So this is our tangent. And here they're asking us to find the length of this tangent. Of course, in terms of t, right? Okay, fine. So the easiest way for us to find the length of the tangent, since we don't know the coordinates of the point B, it's just to connect the radius and also to connect the distance from A to the center of the circle. And since we realize that we are dealing with a right-angled triangle, then we can easily use the theorem of Pythagoras, all right? But then what does the theorem of Pythagoras say? Well, it says the square of the hypotenuse is equal to the sum of the squares of the two other sides, right? But then since we are looking for the length of this tangent AB, so we can manipulate the theorem of Pythagoras and say AB squared equals AM squared minus BM squared. But remember the most important thing, BM is just the radius of a circle. And if you remember well, you said your R squared is 25 when finding the equation of this circle, right? Okay, fine. So since we don't know the coordinates of B, then it doesn't make sense for us to find AB in terms of T and X. Think of it. It's two unknown variables. We won't reach any point. And if you look at what the question is asking, we need to find the length of AB in terms of T only. So how do we get the length of AM? Well, easy, or rather the square of AM. We say, well, it's going to be the x value at A minus the x value at M plus the y value at A minus the y value at M. So it's supposed to be -5, right? But of course, we can just write this as +5. So this is AM squared. Then since we know that BM is the radius, which is 5, so it means the square of the radius is 25. So what? Well, now we need to expand this part and expand that part as well. So using the FOIL method, we are simply going to get t squared minus 6t plus 9. And for this one, we simply get t squared plus 10t plus 25. And then we come and say minus 25. Okay. Then t squared plus t squared, well, it's 2t squared. Of course, these ones will safely cancel out. And if you say 10 minus 6, you get a 4. And, well, the 9 goes alone, so you'll simply say plus 9. But what is it that you have here? It's AB squared. So in order for you to find AB, which is the length of the tangent, you are simply going to take the square root on both sides. And this is exactly what they asked you to show. Now, what does the next question say? Which, fortunately enough for us, is the last question. So, well, here they say, please determine the minimum length of AB. So how can you find the minimum length of AB? Well, it's very, very easy. You can choose to optimize if you like, because you have done calculus already. So you can use optimization because you understand that at the maximum, in fact, minimum, that's where the derivative is equal to 0, right? But the easiest way out is actually to use grade 11. That formula that says x equals negative b over 2a. Why? Because we understand that the minimum point or the minimum value occurs at the turning point. And it is actually the y-coordinate of the turning point. So, which is why we are going to find the x-coordinate of the turning point, or in this case, the t-coordinate of the turning point. Now, this is what I want to tell you. Do you see the presence of this square root? It's going to throw you a little bit off, right? Because it's going to confuse you. Okay, how can you use the formula that says x equals negative b over 2a if we have the square root there, right? Because you're used to applying it on functions, or we can say quadratic functions or expressions, not something that has the square root. Well, you're going to ignore the square root and do what you are used to doing and actually find the length, right? Which is the y-coordinate. And after that, you are simply going to say the square root of that answer is going to give us the minimum length. So let's go ahead and do that. Well, we need to begin by finding the t-coordinate of the turning point. And the value of b in this case is 4. And the value of a, in this case, it is 2. So it means the turning point is going to be where t is negative 1. Then we come back and substitute our negative 1 here. So right away we can come and say, well, the minimum length, it's just going to be the square root of 2 into negative 1 squared plus 4 into negative 1 plus 9. So negative 1 squared is 1, and 2 plus 9 is 11. 11 minus 4 is just going to be 7. Do you see that? You just focus on the inside function, but then when you find the minimum length, you'll say it is the square root of this 7. So this should be the minimum length.